All right, in this video, we're going to be using the elimination method again, but you'll notice now we have 3 separate equations and 3 different variables. So if I'm going to use the elimination method, I'm going to start off like I did with when I had 2 equations and 2 variables. I want to eliminate any one of the variables, the x, the y, or the z. So what I'm going to do is, looking at this bottom equation, I notice that my x is 1x. It's easy to make a 1 be anything you want it to be by simply multiplying it by whatever it is you want it to be, right? So I'm going to use the x to eliminate the x in that middle equation. So since it's 2x, I am going to need this x to be negative 2x. So I am going to multiply everything on both sides by that negative 2. Let's see what that gives me. That gives me negative 2x. Negative 2 times y gives me negative 2y. Negative 2 times z gives me negative 2z equals 2 times negative 2, which gives me negative 4. So now I can add that to the middle equation. So I'm just going to rewrite the middle equation to kind of keep my work organized underneath this new equation. So it's 2x plus y minus z equals 2. So again, I am just rewriting this equation so that I can now add these together and eliminate my x's. So when I do that, I have negative 2y plus y gives me negative 1y. Negative 2z minus z gives me negative 3z. Negative 4 minus 2 gives me negative 2. So what I have done now is I have created an equation eliminating my x's, but I still have y's and z's. My goal is to get it down to just one variable so that I can solve for that variable. So since we eliminated the x's once, what we want to do is eliminate the x's again without using the same exact equations. So what I'm going to do is I'm actually going to mess with this bottom equation again, at the bottom of my originals. So this same one, but instead of using it to eliminate the x in the middle equation, I'm going to use it to eliminate the x in the top equation, which is a 3x, which means I need to multiply by negative 3 this time. So let's see what happens when I multiply this equation by negative 3. So I'm going to write its answer to the left of that squiggle line that I just made. So I've got negative 3 times x, which gives me negative 3x. Negative 3 times y, so negative 3y, and then negative 3 times z gives me negative 3z, and that's going to be equal to negative 3 times 2, which gives me negative 6. So now I want to, that top equation, I'm going to write it below the new equation that I just created. So I'm going to have a 3x plus 9y plus 6z equals 3. And now I can add these together because, again, the x's will eliminate. So that's what you're wanting to do. You're wanting to eliminate the same variable 2 times without using the same exact 2 equations. So now let's see what I have. So negative 3y plus 9y gives me 6y. Negative 3z plus 6z gives me plus 3z equals negative 6 plus 3 gives me negative 3. So these 2 equations, this one and this one, I want to write one on top of the other. So I'm just going to bring this equation over here and rewrite it under the other one. So I'm just bringing this one over. So negative y minus 3z equals negative 2. So now you have 2 equations in 2 variables. So you want to eliminate another variable. And if you'll notice, look at your z's. They are set up very nice because adding them together, just like they are, will eliminate. So 6y minus y gives me 5y. My z's eliminate equals negative 3 minus 2 is negative 5. So now I'm down to one variable, which means I can divide by that, 5. That's a 5. So y equals negative 5 over 5, which gives me negative 1. So what you are finding is called an ordered triple, because you are going to find all 3 variables, your x, your y, and your z. So far you have found your y, which is negative 1. What you can do with this y is take it back to any equation that you see that has a y and just one other variable. So either that equation or that equation. So either one of those. So let's say I'm using this equation over here on the left. So I'm going to replace my y with negative 1. So I've got this negative. Then I'm going to replace my y with negative 1 minus 3z equals negative 2. Well, this right here, negative 1 times negative 1, so that's going to turn that to positive 1 minus 3z equals negative 2. So now, look at your equation that you're solving. The only thing that we don't know in that equation is what the z is. So I'm going to solve this for z. Subtracting the 1. So now I have negative 3z equals negative 3. So if I divide both sides by negative 3, now I know what z is. Negative 3 over negative 3 is positive 1, which means now you know the z. So now you know the y and the z. So now you can take it all the way back up to the very top and solve for x. You're going to replace your y with the negative 1 and replace your z with the positive 1. So when I do that, I have 3x plus 9 times my y is negative 1 plus 6 times my z is positive 1 equals 3. So now you have an equation, and look what the only unknown variable is. It is that x. So let's see what we have here. 9 times negative 1. Positive 9 times negative 1 gives me negative 9. Plus 6 times 1 gives me 6 equals 3. I can put these together. They're on the same side. So 3x negative 9 plus 6 gives me negative 3 equals 3. Solving for x, so I'll add the 3 to both sides. So 3x equals 6, and then divide by 3. So Those 3's cancel. So you are left with x equals 2. So when you enter your answer, this is what it's going to look like, an ordered triple. You just use these parentheses from your keyboard and then enter the x, y, and z. I am only going to work one of these for you by hand because your next video will be working these problems using your calculator.